Hi. This quest is based on the game Risk. If you're not familiar with the game Risk, then I suggest you pause the video right here and read through this. Now, we are going to generalize the rules of dice throws in Risk, and so we have two integer vectors, and the left one is the attacker and the right one is the defender, and we have to find out how many armies the two players lost. So we're going to have a large example where the attacker attacks with 5 armies, as if that was allowed, throws 5 dice, and the defender defends with 3 dice. And so we want to find out how many each player loses. So we can see here that the attacker matches over here, so the attacker loses, and then the attacker has more than the defender, so the attacker wins. That means the defender loses. And then the third one, the attacker has less than the defender, so that clearly the attacker loses an army here. So all in all, we're only considering the first 3. The attacker loses 2, and the defender loses this one. Now let's compute that. The rule is that the attacker wins if the dice show if the attacking die shows more than the defending die. We are given our throws here already sorted, so that makes things easier. But we need to take care of this discrepancy in length, potential discrepancy in length between them. And an inefficient but elegant way of doing this is to simply compare all values. So this is an outer product. It's not really a product, it's really a comparison. We are comparing all the values here with all the values over here, even though we actually only want the corresponding values compared. And that gives us a comparison table where we have the rows here correspond to the 6 and 6 and 4, 2, 1, and then the columns here compared to the 6, 5, and 5, and so we can, and this is 1 for true and 0 for false, so we can see here that this is the right comparison with the 6 and the 6, and it's not greater than. This is the 6 and the 5, it is greater than, and this is the 4 and the 5 that is not greater than. So we want the diagonal. And we can get the diagonal in APL by using a transpose, a generalized transpose. So a normal transpose, that just flips the x's. But the generalized transpose, we take a mapping as the left argument to the transpose function, and we can say where we want the particular x's to go. So if I want the first axis to become the first axis and the second axis to become the second axis, that has no effect. If I want the second axis to become the first axis to become the second one, and the second one to become the first one, then we get that normal transposing. However, if I map both of them to the same axis, that means as we traverse this array, and instead of traversing first along the major axis, leading axis of the rows, and then along the columns, every time we take one step down, we also take one step right. So essentially, we're collapsing the two axes into one and taking the diagonal between them, and that gives us this diagonal that we were looking for. Now, this is who wins, but we're actually interested in who loses. So we want the opposite of the greater than, which is less than or equal to. Okay, now we want to know how many there are. So really what we want to know is how many ones are there and how many zeros are there, because the ones indicates that the attacker lost, and the 0 indicates that the defender lost. And we can do this in various ways, and you can see the description for this video to go to the chat, the event that happened, and it has other ways to do this. But I'm just going to show you one way to do that here. I'm going to make this list, this vector, into a column, and then I'm also going to negate it, and I'm going to concatenate them together. So this is a function of the result of this function, where we're taking the columnized form and concatenating the negated form. So this column represents the attacker's losses, and this column represents the defender's losses. And now you can see all we need to do is sum the columns. And that's exactly what we're going to do with the leading or first axis plus reduction. And that gives us 2, 1, which is exactly the result we were looking for. So we can take this whole construct, give it a name, and then we can go in and substitute it in here. Then the whole thing reads a little bit nicer. Thank you for watching.